Something impossible just happened, and the silence from NASA is deafening. On November 11th, astronomers at the Nordic Optical Telescope captured images of interstellar object 3I Atlas, 2 weeks after it passed through its closest approach to the Sun. What they found contradicts every model we have for natural comets. 3I Atlas survived, intact, as a single body. But here's why that's terrifying. According to Harvard astrophysicist Avi Loeb's calculations, based on the mass loss rates observed near perihelion, this object should have disintegrated into at least 16 separate fragments, possibly dozens more. It didn't. And the implications of that survival are forcing scientists to confront a possibility they've been dismissing for months. Let's start with the raw data, because this is where NASA's silence becomes suspicious. Between August and late October, 3I Atlas went from losing 330 pounds of material per second to approximately 4.4 million pounds per second as it approached the Sun. That's a 10,000-fold increase in mass loss. Loeb calculated the exact power requirement. At perihelion distance, the Sun provides about 700 joules per square meter per second. To sublimate enough ice to account for that mass loss, 3I Atlas would need an absorbing surface area of at least 617 square miles, equivalent to a sphere 14.3 miles in diameter. But here's the problem. Hubble Space Telescope observations from July 21st established an upper size limit of just 3.5 miles in diameter, potentially as small as 1,444 feet. The math doesn't work. The required surface area to produce the observed mass loss is 16 times larger than the object's maximum possible surface area. For a natural comet, there's only one explanation: fragmentation. The object would need to break apart into at least 16 pieces, dramatically increasing the total surface area exposed to solar radiation. Every model predicted this. Every precedent suggested it. And yet the November 11th images show a single, coherent nucleus with a prominent anti-tail pointing toward the Sun, the same structure Hubble observed in July. No fragments, no debris field, no disintegration. Loeb's conclusion, published just hours ago, is careful but unmistakable. If upcoming observations were to reveal that 3I Atlas was not decimated by the Sun and maintained its integrity as a single body, then we will have to consider that it is something other than a natural comet. We now have those observations, and 3I Atlas maintained its integrity. But the survival is only half the anomaly. It's what's coming out of this object that's raising alarm bells. On November 8th, astronomers captured images showing at least 7 distinct jets emanating from 3I Atlas in multiple directions. Some of these jets are anti-tails, pointing directly toward the Sun, which is physically unusual for natural cometary outgassing. More troubling, these jets are penetrating over 1 million kilometers through the solar wind. In an interview with News Nation yesterday, Loeb explained the mass requirements. We know the properties, the density, and speed of the solar wind, so we can figure out that for a natural comet with the characteristic outflow speed of these jets, there is a lot of mass carried by these jets so that they can penetrate through the solar wind. About 5 billion tons. 5 billion tons per month based on his calculations. But then Loeb said something that most outlets didn't emphasize. The jets may be coming out of thrusters, which can reach much higher speeds for the gas that comes out of them, in which case they don't require much mass. The fuel can be a small fraction of the mass of the spacecraft. He said spacecraft on national television, and here's what makes that statement scientifically defensible rather than speculative. The jet velocity matters. For natural comets, outflow speeds are approximately 0.4 kilometers per second, roughly the sound speed of gas sublimating from ice. Chemical rocket thrusters, by contrast, produce exhaust velocities of 3 to 5 kilometers per second, 10 times higher. Higher velocity means lower mass requirements to produce the same observable jets. If 3I Atlas is using propulsion rather than natural outgassing, it wouldn't need to lose 5 billion tons of material. It would need exponentially less, which would explain why it didn't fragment. Now we need to talk about what we're not being shown. On November 11th, the same day that the Nordic Optical Telescope confirmed 3I Atlas survived intact, Loeb published an essay with a pointed question in the title. As the government shutdown ends, can NASA please release the 40-day-old high-rise images of 3I Atlas? Let's break down why this matters. NASA's Mars Reconnaissance Orbiter carries the HiRISE camera, the most powerful camera ever sent to another planet, capable of resolving objects as small as 3 feet across from Mars orbit. Those images were taken more than 40 days ago. They have not been released. Loeb notes that ESA's ExoMars Trace Gas Orbiter and Mars Express both released their 3I Atlas images within weeks of observation. Those images, while valuable, were taken with less capable cameras at greater distances. HiRISE could have captured the nucleus directly. It could have shown us whether the object surface has discrete venting ports or diffuse outgassing. It could have resolved structural features that would immediately distinguish between a rubble pile of ice and something with geometric integrity. Instead, we have silence. The official explanation, if there is one, would likely cite the partial government shutdown that occurred in October. But as Loeb pointedly notes, space science data releases typically follow standardized protocols that don't require 40 days of bureaucratic delay. The James Webb Space Telescope released its 3I Atlas spectroscopic data within days of observation back in August. Hubble's images were public almost immediately. Why are the highest resolution photographs of this object, taken at the most critical moment of its solar approach, still locked away? Here's something that slipped past most coverage. Avi Loeb just placed an official, financially backed bet with Michael Shermer, executive director of the Skeptics Society, that within 5 years, by December 31st, 2030, there will be undisputable scientific evidence for an atechnological artifact from an extraterrestrial civilization. The bet is being officiated by the Long Now Foundation, an organization that maintains century-long wagers between scientists and public intellectuals. This isn't a thought experiment. This is a Harvard astrophysicist putting money on the table. And his statement explicitly references 3I Atlas. The search for technological artifacts has just started in earnest in 2025 with the discovery of the anomalous interstellar object 3I Atlas. Think about what that means. A tenured professor at one of the world's most prestigious universities is wagering his professional credibility and actual money on the claim that we've already detected evidence of extraterrestrial technology. He's not waiting for SETI signals. He's not talking about future discoveries from the Galileo Project's new observatories. He's talking about 3I Atlas right now. The bet's timeline is revealing. December 19th is when 3I Atlas makes its closest approach to Earth, just 170 million miles away. That's when Hubble and Webb will get their best imaging opportunities. Loeb expects decisive data within weeks, with confirmation within 5 years. That's not the timeline of someone hedging speculative theories. That's the timeline of someone who thinks the evidence is already compelling and just needs technological confirmation. December 19th is 5 weeks away. On that day, every major telescope on Earth and in orbit will be trained on 3I Atlas. Spectroscopic analysis can measure the exact velocity and composition of those 7 jets. High-resolution imaging can search for multiple fragments or confirm a single integrated structure. The data will tell us whether 3I Atlas is ejecting material at 0.4 kilometers per second, the signature of sublimating ice, or at 3 to 5 kilometers per second, which would indicate something entirely different. But here's what should concern everyone. We had the capability to answer these questions 6 weeks ago with HiRISE. We could have resolved this debate before 3I Atlas disappeared behind the sun. Instead, those images sit in an archive somewhere, unreleased, while the object that survived an encounter that should have destroyed it continues its journey through our solar system. And the only scientist willing to publicly state what the data implies, just bet his reputation that we've already found what we've been looking for. The question isn't whether 3I Atlas is anomalous. The observations confirm that beyond doubt. The question is whether the people with the best data are willing to tell us what it shows.